Hi everyone, my name is Nikhat and I'm going to explain the project Inverted Search. The purpose of storing an index is to optimize speed and performance in finding relevant documents for a search query. Without an index, the search engine would scan every document in the corpus, which would require considerable time and computing power. In this project, we are using inverted index method to search some data. Next we will see what is inverted index. An inverted index is an index data structure storing a mapping from content such as words or numbers to its location in a table or in a document or a set of documents. Next we will see what is its purpose. The purpose of an inverted index is to allow fast full text searches at a cost of increased processing when a document is added to the database. The inverted file may be the database file itself rather than its index. It is most popular data structure used in document retrieval systems, used on a large scale, for example in search engines. Next we will see what are the types of indexing. So basically there are two types of indexing, that is forward indexing and inverted indexing. In our project we are going to use inverted indexing. First we will see what is inverted indexing. Inverted indexing is a data structure that stores mapping from words to documents or a set of documents, that is directs you from word to document. So these are the steps to create an inverted index. That is, first we have to scan the documents and then prepare a list of unique words. Then next we have to prepare a list of indices of all the unique words and map them to a document search. I will explain you with the help of a diagram. So here we have document 1 and document 2. We have stored some random words in both these documents and we have taken these words here. So these are the words which are present in this document 1 and document 2. The procedure to create database is we are going to scan the document first. Here we have document 1 and document 2, where in each document I have some words. We have taken some random words. Here in inverted indexing we are going to scan the documents. Here we are going to scan the documents one after the other and we are going to prepare a list of unique words. In the second step we can see that we have prepared a list of indices of all the unique words and then map them to a document search. So here we are going to create a database in such a way that, for example, if you want to search for the word hi in the database, when you start searching for the word hi, it gives you the location where and all the word is present. So here in inverted searching, the database is created in such a way that if you search for some word, it will direct you directly to the location where and all it is present. For example, if you search the word hi, it will give you the location where and all the word hi is present. It will show you document 1 and document 2 because it is present in both the documents. So here we can see the word hi. It is present in document 1 and document 2. In document 1 we can see hi is present and even in document 2 hi is present. So whenever we search for the word hi, it will direct you to the documents where and all that word is present, in which document the word is present. For example, if you want to search for the word hello, so it will direct you to document 1. It is present only in document 1. It is not present in document 2. So here we are going to create a database in such a way that whenever we are searching any words, it will give you the location where and all the word is present. It will also show how many times it is present in a particular file. So all such details we are going to get. So before getting all such information, we have to create it. This is how we create a database using inverted indexing method. So this was all about inverted indexing method. Next we will see forward indexing. Forward indexing is a data structure that stores mapping from documents to words, that is directs you from document to word. So these are the steps to create a forward indexing. Scan the documents and prepare a list of unique words. Map all the words to a document as an index. I will explain you with the help of a diagram. So here we have document 1 and document 2 and we have stored some random words in both the documents. Here we are taking document 1 and document 2 and we are preparing a list of indices with respect to documents here, and we are going to list all the words present in the document. Since we have two documents, two indices will be created. So here we can see these are the two indices which we have created with respect to document 1 and with respect to document 2. Forward indexing will direct you from document to word. So here, as you can observe, all the words which are present in the files, they are just mapped. So here we are creating database with respect to documents, not with respect to words. For example, if you want to search for the word hi, since we have created the indices with respect to documents, you will start scanning the document 1 first. You will come to know that the word hi is present for one time now in document 1, but you cannot simply just come out of document 1 because we don't know for how many times it is present. You will just again continue scanning document 1. You will scan hi, hello, how are you, and then you will come out of document 1, and again you will go to document 2, and again you will start searching for the word hi. Once again, after getting the word hi, still one word is remaining in document 1, and still you will continue for searching the word hi, because we don't know for how many times this word hi is present. This is how database is going to be created in case of forward indexing. In case of forward indexing, we map with respect to documents. That is, we prepare the indices with respect to documents here, whereas in case of inverted indexing, we prepare the indices with respect to words. Now we will see the real life example of inverted index and forward index. So the real life example of inverted index is index at the back of the book. If you take any degree level or plus 12 textbook or any standard textbook, we used to have index at the back of the book. Like for some technical word, there will be some page number present in front of it, like where and all that particular word is used in the entire book. So here word to document search happens, that is inverted indexing. Next we will see the real life example of forward index. So the real life example of forward index is table of contents in the book, which directs document to word search. Next we will see advantages of inverted index. So the first advantage is it is easy to develop. So inverted index is very easy to develop, and the next advantage is it is used in document retrieval system, like for example search engine. The example of search engine could be Google. So why we are using inverted indexing is whenever you type a word, you will understand where and all that word is present in case of inverted indexing, whereas in case of forward indexing, it will scan each and every document. For searching a single word, it will search for a single word in each and every document, which is a time consuming process. Forward indexing takes more time as compared to inverted indexing. That is the reason why we are using inverted indexing method in our project. Next we have requirement specification. Implementing this search program mainly consists of two important functions, that is indexing and searching. First we will see what is indexing. By indexing, we are creating a database file which contains the index of all words. So this can be termed as database creation also. All the files whose index are to be created are selected and inputted to this function. All the files are parsed and words are separated and indexed. They are arranged in sorted order. For this, a sorted linked list or hashing is used, which will store the words and the related file details. The index thus created is then stored in the file as database. This file is later used in searching. While the files are removed or added, this index file is updated. Next we will see what is searching. Once the indexing is over, we have the searching. The text to be searched is inputted, which is passed into words, and those words are searched in the index file. To avoid the overhead of reading the file again, the file is converted back to a linked list or hashing program in which the words are searched. The information about the files which contain the words are collected. The ones with more matches are filtered and produced as the result. Next we will see the operations. So the first operation is to create a database, and next we have to display the database. Next we have to search the database, and next we have to update the database, and last we have to save the database. So we will see this operation one by one. Now we will see the design. So first we will have module 1. In module 1 we are performing main indexing, that is we are going to perform the operation in the main file. So the function here is this main program calls the indexing function. It reads a text file for the input files, and as an output it creates an index file in the same directory. For updating the database also, this program can be called anytime. So the function used here is int main int argc char star star argv. So this is file 1 main indexing. Next we will see file 2 indexing. So the operation here is to create or update the database. Next we will see the function. Select the files from a text file. The list of the files can be provided by storing all the file names in another file list. So the names of the files which are to be documented are provided by this file. When a file is added or removed, file list is changed accordingly. So read the file names and start indexing. So here we are going to use the function create database file star file list. Next we will read the file one by one. First we have to open the file, that is file list, and read the names of the file. This is an iterative process which reads one file name from the file list and open that file in the read mode. So the function used here is word star read underscore data file star file word star word list char star file name. So we have to use this function. Next, the process of parsing starts. First, in this process we have to select the words. Then next, character by character are read from the file. When a character other than alphabet is read, it is considered as the delimiter of words. So the alphabetic characters from words, when one word is collected, it is now sent for storing. For space reduction, avoid prepositions, that is in, is, from, etc. should be avoided, and conjunction and, for, etc. should be avoided, and articles an, the, etc. should be avoided. In the text files, the occurrence of these words will be more. Then next we have to store in the index list along with the file name in the sorted order. Index list can be stored using linked list or hashing. Here we are implementing with linked list. The word is now stored in the linked list along with file names. So the linked list is a structure storing a word, list of file names, pointer to next list. The word is inserted in the list in the sorted order. For arranging in the sorted order, the words in the list are string compared with a new word to be inserted. Before inserting the word, make sure the word is not repeated. If the word is already present, select the same word node and add the file name in the file list. For the same words in the same file, no need of adding the same file name again. Instead, for advanced search, you can increment the count of the word in the same file. For this, the node should contain a count number which reflects the weightage of each word in each file. Once the file reaches the end, it can be closed and the next file in the file list can be opened in the read mode, and the process continues. This is done for all the files in the list. So when the files are over, a very big index, that is a linked list, is formed. So here the function, that is word star store underscore word char star file name word star word list should be used. Then next, write the index in the output index file. Here all the files are opened and read. Words are listed. Now this list is to be stored. For this, a new database, that is a new file, database file, is created and opened in write mode. Now the words along with file list, that is each node contents, are returned to the database file. In the file also, the words should be written in sorted order. After that, the file is closed properly. So here the function write underscore database file word star word list file star database file is used. So that was all about module 1. Now we will see module 2. In module 2 we are going to use two files, file 1 and file 2. In file 1 we are going to see main searching, and in file 2 searching. So in file 1 we have main searching, that is this program can be called whenever a search is needed. This program takes user input text and produces file names in return. The next we have file 2 searching. In this, first we are going to write the index file to a index list. Before starting search phase, open the database file and read the word structure and store it in a linked list. This helps to avoid the overhead of accessing files from the file always will be reduced. So open database file in read mode, read each word and related files information and store in a linked list node. Read till the file is completely converted to a linked list. Make sure the sorted order is still maintained. So here we are going to use the function word star create underscore index list file star index underscore file word star index underscore list. Then this is written index list. Then next we are going to take the input from the user. Now the search phase is going to begin. To search, collect the user input text. It should be stored in a character string. Then next we are going to divide it into words. The character string can be tokenized into words. It can be done in the same way. The file is passed. The non-alphabetical characters can be used as a delimiter. So here we are going to use the function char star string underscore token char star input underscore string. Then next we are going to search. In the search, first we are going to search each word in the list. Each word is now used to search in the linked list. The word has to be compared with each word in the linked list. When found, the file details can be retrieved. Since the linked list is in sorted order, the complexity of searching the word in the complete list can be avoided. While string comparison, if the word in the linked list is greater than the word to be searched, it shows the word doesn't exist in the list. Then next we have to create an output index based on words matching. For the match words as an output index is needed to be created. For this, an array or another temporary linked list can be created. In this, file name and count is stored. For each word match, the corresponding file count is incremented. So to create an output index, we are going to use this function which I have shown here. That is struct underscore file char star file name, the next int count, then next struct underscore file next. So this is the function which we are going to create an output index based on words matching. Then next we are going to select the files with maximum matching and print the results in the order. When all the words are searched, the output list is formed. In this, the file with max count representing maximum word match can be selected and displayed. For advanced search, weightage of words stored in the database linked list can also be used, so the result will be more accurate. So here we are going to use the function display underscore output output underscore list. So this was all about module 2. Now I will show the demo of the project, like how this project is going to work. First let's see which all files are needed. So first we need this .c file. This C file contains the logic to create a database. This C file will contain the logic to display the database. This C file contains the logic to insert at last, and this .c file will have the logic to save the database, and this .c file will have the logic to search the database, and this .c file will have the logic to update the database. And here we have one header file, that is inverted underscore search.h, and we are using here two text file, that is file1.txt and file2.txt. Using these two files we are going to create the database. So I will show you all. First let me open my terminal. So I will show what is present in file1.txt and file2.txt. That is, I'm going to show the contents of file1.txt and file2.txt. So this is the content of file1.txt. Now let's see the contents of file2.txt. So see here, so this is the content of file2.txt. Now let me compile my code. So I'm going to compile all the files using this command gcc start.c. So I'll get one executable file, that is a.out. I'm going to execute this file and I'm going to pass the file that is file1.txt. So now I will get like this, that is successful inserting the file file1.txt into file linked list. So this all options will be displayed. From this option I have to choose which operation I have to perform, that is whether I have to perform the operation to create the database, or whether I want to display the database, or I want to update the database, or I want to search any database, or I want to save the database. So first let's see to create a database. So I will enter the option 1. So now it will display successful in creation of database for file1.txt. So again it will display do you want to continue. So I will press yes, I want to continue. So again it will ask me the option. So now let me enter the option to display the database. So I will enter the option 2. So it will display me the contents of file1.txt. So I will show you all. So see here, so these are the contents of file1.txt. So again it will ask me whether I want to continue or not. So I will press yes. Then again it will ask me the option which operation you want to perform. So I am going to perform the operation update database, that is option 3. So I am going to press option 3. So it will ask me enter the file name which you want to add in a database. So I want to add file2.txt. So the contents of file2.txt will also be added into the database. So see here, successful in inserting file2.txt into the file linked list, successful in creation of database for file2.txt. So again it will ask do you want to continue. So I'll press yes. Then next, again it will ask me the options, whether which option you want to perform. So I will display the database. I'll press option 2. So it will show me the contents of both file1.txt and file2.txt. So here you can see these are the contents of file1.txt, and here it will show the contents of file2.txt. Again it will ask me the option whether you want to continue or not. So I'll press yes, I want to continue. Then next it will ask me which operation you want to perform. So I want to perform the operation search. So let us search for some words. So I'll press option 4. So it will ask me enter the word you want to search. So I want to search the word hi. So this will display me in which file this word hi is present. So let me press enter. So see here, the word hi is present in 2 files, that is in file file1.txt and in file file2.txt. So see, it is present in file1.txt for 7 times and in file2.txt it is present for 1 time. So again it will ask me whether you want to continue or not. So I'll press yes, I want to continue. Then it will ask me which operation you want to perform. So we have seen all this operation, that is to create a database, to display the database, update the database and search. Now we will see how to save the database. So we'll enter the option 5, that is I want to save the database which I have created. So it will ask me enter the file name you want to save in database. So I will give backup as the file name, that is backup.txt. So I have given the name of the file as backup.txt. So here the contents present in file1.txt and file2.txt will be stored in this backup.txt. So I will show you all. So see here, it is showing database saved successfully in backup.txt. Do you want to continue or no? So I will give no, because I have shown all the operation, like how to create the database, how to display the database, how to update the database, how to search for a word, the next how to save the database. So I'm giving here option no. So it will come out of the project. So I will show you. So see here, it will come out of the project. Now if you want to see the contents present in this backup.txt, so we have to give cat backup.txt. So here it will show me the contents present inside this cat backup.txt. So this contents is nothing but the contents of file1.txt and file2.txt. That whatever words are present in file1.txt and file2.txt, those words are stored in this backup.txt. So this was all about the project inverted search. Thank you.